All right, here's your MoM diagram review. So as you're drawing MoM diagrams, you're actually taking a whole bunch of different chemistry knowledge and putting it together in a picture. So here are the pieces. One, covalent compounds versus ionic. Remember, covalents have two or more nonmetals. And on the periodic table, remember we have that staircase, so the nonmetals over here on the right side, and hydrogen. All right, so things like oxygen, nitrogen, carbon, those are nonmetals. All right, and they're held together by covalent bonds. These are really strong and do not break. Well, let me change that. They can break, but if you dissolve them, they just stay together. All right, ionic compounds are metal and a nonmetal. All right, and these are held together by attractions. All right, so again, for those covalent compounds, you're going to see something like this. This means it has bonds. If we have an ionic compound, maybe we have something like this, where you just have them sitting next to each other because we're showing that they're attracted to each other without showing that bond, because that hopefully indicates that they're easier to take apart. Oops. Okay, next one. Having trouble here. There we go. Okay, so then you have to think about the formula. All right, you have to use the subscripts in the chemical formula to figure out how many of each shape that you draw. Remember, if you're dealing with a polyatomic ion, so CO3, OH minus, PO4, 3 minus, just to name a few, you're only going to use one shape. All right, because the reason we're going to have you do that is the polyatomic ion, it will stay together. Like it shows up on both sides, so there's no need to show all the bonds within those polyatomic ions because they're just going to stay together. So we're just going to simplify it and just use one shape for each one. Again, if you have covalence, you have bonds. If you have ionic, you don't have bonds, you just have your attractions. All right, so let's try just a few of these. Okay, so first of all, we want to identify things as ionic or covalent. So you can go through, try that first, and then pick up the video again to check your answers. All right, so the whole top row are ionic, the whole second row are covalent. All right, so then for actually modeling it, now I have to pay attention to these subscripts. So this first one, I have a calcium 2+ ion. I'm going to use a square. I have chloride ion. I'm going to use a circle. And then when I put it together, because it's ionic, there's no bonds. I'm going to have just two circles on the outside. Again, opposites attract is what I'm going to keep track of. So the positive in the middle, the two negatives on the outside. When I have carbon and oxygen, my oxygen, I'm just going to use a circle. My carbon, I'm going to use a square. All right, so you notice the same symbolism as above, but now to show that it's covalent, I'm actually going to put the bonds in. So those bonds, again, are really strong. The carbon and the oxygen will stay bonded together unless there's a chemical reaction. Okay, so second one, here's where we have our polyatomic ion. So you just have to recognize that, hey, that is PO4, 3 minus. I'm going to make that a triangle, and then I have my Na plus. I'm going to make that a colored in circle. All right, so then I have to look and see that I have 3 Na pluses and then just one PO4 3 minus. So I'm going to put that PO4 3 minus in the middle, and then on 3 of the sides, put a Na plus, because again, opposites attract. Down below, carbon, I'm going to use a square again. Hydrogen, I don't know, I'm going to use a triangle. But this is covalent. I have one carbon, and then thinking back to our Lewis dot structures, hydrogens can only form one bond, so they're going to be on the outside. Finally, on the far right side, again, I recommend you stop the video, try it yourself, and then check your work. We have a calcium 2+. I'm going to change colors here. We're going to go with a pink circle for that one. And then we have the PO4 3 minus again. We'll go with a triangle on that one. Again, now I've got to pay attention. I've got 3 of the calciums, 2 of the phosphates. So I need to arrange these so the opposite charges are touching each other. So there's a couple ways to do it. Simplest probably is just to put them in a line, but you could do a couple different things. You could do this, I don't know, just as long as you have 2 of the phosphates, 3 of the calciums, and opposite charges attracting each other, you are representing what we want you to show. All right, then finally we have our oxygen and our hydrogen. So again, hydrogen, I'm going to go with the triangle again. Oxygen is circle. So this one, thinking back to the Lewis dot structures, oxygen's in the middle, hydrogen's on the outside. But again, it's covalent, so I've got bonds. All right, so again, that's now this has kind of put together the ionic and covalent and also showing the subscripts. All right, then final thing is states of matter. You've seen this multiple times. And so then I think I'm just going to let you work at this point, you probably just want to practice some of them and then check your answer. So go ahead and start doing that. Hope this video helped.